Hello, this is video 69. This video I'm going to start our discussion of pressure. We'll be talking about pressure for a few videos. We'll start with the basic definition. I'd like to start this by showing you a few pictures. We have a book, an orange book here. It's called The Joy of Physics. That is a true title. There is such a book. And then there's another physics book that is on its side here. And if I asked you which one exerted more pressure on a table, what would you say if I told you they both had the same mass? Well, it turns out that it would be the orange one. You can see that all of the weight of the book is concentrated on a smaller area touching that table than the blue book. And with that kind of thinking, if you look at this person lying down on a bed of nails, and I ask you, well, how can she do that without it hurting her, without those nails piercing her skin? Well, you can also think that her weight is distributed over a big area. So over each individual nail, you don't have that much weight on it, right? But if you just had an apple on the nails, it would get pierced because there you have more weight on that small area. But when it's a whole person and that weight is distributed over a large area, then it's not going to pierce the skin. So that gets us to our definition of pressure, which is the force per unit area that one object exerts on another. We use the big letter P for pressure, so pressure equals force per area. The units for pressure, you might think it would be Newton per meter squared, but we're going to call it a Pascal, abbreviated PA, that's the SI unit. Pressure is also a scalar, so it does not have a direction. Let's do a simple example, calculating pressure. When you're poking a balloon with your hand, then it usually doesn't pop the balloon. But if you poke the balloon with a needle, then that's going to pop the balloon. So the reason that it doesn't pop when you poke it with your hand is because your finger has a relatively large area, and so it doesn't exert enough pressure on the balloon to pierce it. We can calculate the pressure. In this example, it says find the pressure exerted on a balloon if you press with a force of 2.1 newtons using your finger. So pressure equals force per area. All we have to do in this example is plug in our values. 2.1 newtons over 1 times 10 to negative 4 meters squared. When we do this, we're going to get 21,000 pascals. Remember, newtons per meter squared is equal to a pascal. So you might think that this is a very large pressure. It looks like a big number, but we'll learn very soon that this amount of pressure is less than the pressure due to the atmosphere. So all that air that is weighing down on you exerts a lot more pressure on you than your finger on that balloon. Let's do one more thing in this video, and this is to start our discussion of the atmosphere, but it's just looking at the pressure due to weight of a fluid. So we just talked about that pressure equals force per area. So let's see what happens if the force is actually the weight of something. So in this picture here, we have a container filled with some liquid, and that liquid, all this blue liquid here, it has some weight. Weight equals mg. So that's a force that is pressing down on this circular area that is down here. So that means that this liquid exerts a pressure at the bottom of the container. How much pressure does the liquid exert? Well, it's only due to the weight of that liquid. So we replace the force by mg. We have mg over area. Now, it turns out that this is equal to rho gh. We're going to see rho gh a lot in the next few videos. The way that you can figure this out, although you're not going to have to derive it, is by looking at this picture here that reminds you that the volume of this cylindrical surface here is the area times the height. So you can replace the area here by the volume divided by the height. And then you can plug that into this expression here. You're going to get mg over vh, v over h. Then you can multiply by the reciprocal. You're going to get mgh over v. And hopefully you recognize that mass over volume that we've been talking about is density. So that's how we got rho gh. You're not going to have to derive it, but when you see this term rho gh, what you want to think is, okay, rho gh is the pressure due to the weight of some kind of liquid that is pressing down on that area. So it's giving you that pressure at the bottom of that liquid. So that's it for this video. We just started talking about pressure, and now we're going to be able to extend this discussion of finding the pressure due to the weight of the whole atmosphere pressing down on us.